in water. So waters make life on Earth possible. 70% of the Earth is covered by water. And water is the main component of our cells. So inside the cells, we have water, also outside of the cell. And water is the only common substance exists in all three states in the nature environment. So we have the solid, we have the liquid, we have gas. Okay, so the liquid inside the cell, that's the cell. The liquid inside is called intracellular fluid. Sometimes we call them ICF, intracellular fluid. And the liquid outside the cell, including this one, also the water in the plasma. Blood have the blood cell and plasma part. So both of them outside, if the water stay between the cell, called interstitial fluid. If the water stay in the blood, called the plasma. Both of them are water outside the cell. So outside the cell, we call them extracellular fluid. Sometimes we call them ECF, include interstitial fluid. That's the liquid between the cell. And also plasma, that's the liquid in the water. Okay, so next thing. Water can freely go through the cell membrane. So it can move in, move out of the cell. That means the water here, if you drink water, water will go to your blood and then go to interstitial fluid, then will go to your cell. That's how you got to rehydrate it after you drink water. But if you put cells into a solution, which is not the same concentration of your cell, something gonna happen. Means water can either move in, make the cell swell, or water can move out, make the cell shrink. And if that happens too dramatically, neither one is good. We talk about homeostasis. So ideally, we want the water for the cells into the solution. Water can move in, can move out. They need to be balanced. So the cell will remain the same shape. This time we use this artificial cell to do the experiment. In your body, we use red blood cell as an example because red blood cell look like a donut. It's easier to see the shape change. So when you put the red blood cell into the solution and then you scoop the cell out, it still look like a donut with a equally amount of water move in and move out. And equal means iso. So this solution is isotonic. So isotonic solution make the cell pretty happy, still remain the same shape. If you put the red blood cell into a solution, and after a while you take the cell out, you feel the cell swell. And a big word to say this red blood cell swell is hemolyze. Sometimes use the verb hemolyze, L-Y-Z-E, hemolyze. Both of them means the cell swell or burst. Sometimes means the burst. You don't see the red blood cell. And why it burst? Because more water move in and the cell swell or burst. Why water have to move in? Because you have more solid. The solid is the salt inside the cell. That's called a solid. More solid inside than the outside. That's why water always feel like they have to go to dilute the solid. So when you have more solid inside, water will move in to dilute the solid. When that happens, the cell swell. So apparently this solution, its concentration is lower than the ICF, right? ECF concentration is lower than the ICF. ECF is the solution outside, ICF the solution inside. So ECF concentration is too low. That's why the cell water move in and the cell swell. So too low means hypo. So hypotonic solution make the cell swell or hemolyze the red blood cell. And I will test you this because you are going to the health field. You need to know this. So for example, you put the red blood cell into a distilled water. What happens is distilled water will keep moving in and the cell will swell and burst. So you find when you get thirsty, you drink water. But if you drink too much water too quickly, it's actually bad. This can happen. Okay, the third one, you put red blood cell into a solution, and after a while, the cell shrink, or we say crenate. Crenate is a big word to say the cell shrink. Why the cell shrink? Because water move out to dilute, the solute outside. So apparently outside has more solute. More solute means high. So higher, hyper. So hypertonic solution make the cell shrink. And a good example is salt. 100 years ago, people don't have a fridge and they want to keep the meat for long. They just cover the meat with salt. It's a super hypertonic situation because the water will move out of the cell. And then when the water move out of the meat to dilute the salt, no bacteria can survive. That's how they keep the meat for a long time. So hypertonic solution crenate red blood cell. Isotonic make the cell stay the same. Hypotonic solution hemolyze the red blood cell. So we find if you drink pure water, that's good. But if you drink too much, you can turn the isotonic, that's your body environment, into a hypotonic solution. So drinking too much water too quickly may not be healthy. And it's called a water intoxication. It actually happens. This lady, she died about 15 years ago. She attended competitions held sponsored by the local radio station. They asked the competitor to drink water and hold a pee. The winner take home the shiny wee, and actually she won. She won, but the price she paid is her life because after a few hours she died. She drank 2 liter water in 10 minutes. And the reason she died is, now you know the reason, right? She turned her body solution into hypotonic, drink too much water, dilute her ECF because water will go to the blood, become plasma, and then it will go to the ECF. So eventually dilute too much, that's hypotonic. And that also means you should not drink seawater because seawater is very salty. The reason it's very salty is a hypertonic solution. Its concentration is 3 times higher than your body, than your ICF. So if you drink seawater, what happens is it's hypertonic. So the water move out of your cell. Your cells shrink more. You actually die faster. So when you get dehydrated, it's gradually you lose water. Your isoton, your cells gradually turn into this. And that's why you feel thirsty. And you drink seawater, make it worse. Your cells shrink more. So that's the osmolarity. You need to know hypertonic, hypotonic. Okay, the rest is easier. Water is a polar molecule. We talk about it because it's a polar covalent bond. So water is a polar molecule and you partially negative head, partially positive side. So it become a perfect solvent for salt because when you put salt into water, it will become ion and you can always find the partially positive head to cover the anion and partially negative head to cover the cation. So water become perfect solvent. And water dissolve a polar molecule. So water is a polar molecule. So if the molecule is polar, it can be dissolved in water. Okay, let's take a break.